So pretty much what you remember about the fun chart. Yeah, yes, we did, Lisa. But on Wednesday was just to talk about the exam. Just like it was a PowerPoint that I posted. I didn't talk about math. It was just, hey, this is what you need to know about the exam, stuff like that. So I didn't think like a video would. It was just like pretty much what I scribbled on the PowerPoint. If anything, you can email me and I can help you out the best I can. All right, so sketch the fun chart the best you can, or if we even remember what that is. The fun chart. All right, the fun chart talks about the function f if we are given f prime, or even some cases f double prime. So if they give us f double prime or f prime, we can find info of f without even knowing like what the heck f is, right? These little shapes, this one's concave up, right? Concave up like a cup, concave down like a frown. And then we talk about increasing, decreasing, positive, or negative, right? So that can be identified by giving the derivatives. So f is concave up if the function is increasing, and f is concave down if the function is decreasing. F is increasing if f prime is positive. If f prime is negative, then f is decreasing. It would be a lot easier if I was at the whiteboard, because then you can see all the hand gestures. But if f double prime is positive, then f is concave up. If f prime is negative, then f is concave down. So hopefully this is a little reminder. And given this right here, guys, we can actually create our little justification just by saying like what we used, what exactly we did, and tying it to the functions we used. Hopefully this is starting to be familiar. Okay, so you don't have to write down the question. If I think just the work would be fine, since I know this would be a printout. So everything I'm going to share with you guys are released exam questions. So today, what we're going to do together is a 2015 one. So if you actually Google or YouTube, a lot of teachers have already done videos on this. So I was trying to find a shortcut on how to do it. So I actually YouTubed some of them, and I was like, and I figured out that the fun chart is actually the pretty easiest way to do it. But there's other videos also, and I can find the links if you want me to, that talk about more of the conceptual stuff by not using the fun chart, just actually using the definitions. So good stuff. Okay, so let's go ahead and read the question real quick. The first thing I see is a graph, and this right here tells me it is f prime. This is huge. Okay, and they even tells you the graph is f prime. This right here, guys, when I was first learning calculus, it really confused me because I didn't understand what it was talking about. But it really just means twice differentiable function of f means you can get f prime, right? The graph itself, f prime, and you can differentiate it twice, so you can f double prime. So no matter what you're talking about this graph, f is continuous. There's no asymptotes, there's nothing. So whenever you hear like this, it is a continuous graph. And then they give you the interval, which we see here is from this -3, including -3, whatever that height may be, and 4, whatever that height may be, which appears to be 0. Okay, the next thing, it says f prime, which is this graph, has a horizontal tangent at these values. So let me find a marker. It says right here, there's a horizontal tangent at this point right here. There's a horizontal tangent right here. and a horizontal tangent right here. Okay, so if we're talking about a horizontal line, hopefully you guys can think about what would be the slope at these lines right here. So this slope would be 0, right? A horizontal line is just 0. So if f prime, just thinking ahead, if f prime is 0, what does that tell us about our function f? Just to brainstorm. So hopefully you're thinking that if there's a slope is 0, there's only one way a slope can be 0 on f. It's if it's either a maximum or a minimum or a saddle point. So hopefully that's crossing through your mind, or hopefully that's something you're remembering. Okay, the last part of information, they say areas. So areas of the region. I know I uploaded this really late, Jocelyn, but if you could you could draw the graph real quick. You don't have to write down the questions. If not, this is a 2015 one, and you could just have that somewhere also, but the graph itself would help out a lot, and the fun chart.
And if you have a screenshot, also screenshot it too. No?
Yeah, that works too. Where did I leave off? Oh yeah, the areas. So keep in mind this one, it's talking about the areas. So like, if as much as I wanted to, I don't know what shape I can do to find this, right? Because normally there would be like triangles, semicircles, lines, and stuff like that. And I can find, oh, area of a triangle. Oh, snap, area of a circle. Oh, snap, area of, I don't know, trapezoid, whatever. That's not the case here. So they gave you the area. So let's go ahead and label that. They're telling me that the area from -2 to 1 is 9. So -2 to 1. So all the way over here. So all this little region is 9 units. Okay. 12 right here is the area from 1 to 4. So all this little section right here is 12. Okay, so that's all the information I know. And we both know that area underneath should be negative, right? Sorry about that. They just told you the area itself in the region. They didn't tell you it's positive or negative. Awesome. So from here, let's go ahead and see what they're asking. So they're telling me, they're telling me the following. They're telling, find all x coordinates for f. So find f has a maximum, and then give your rationale, your justification. So we need to find out when there's a max. So I'm gonna go ahead and go to my fun chart. So let me just try it real quick, since I haven't discovered how to copy paste within PowerPoint yet when I'm writing. So I don't, sorry guys. And minus, okay. So let's go ahead and think about this. If I want a maximum in my f, right? A maximum, how does that occur? Well, let me think about just a maximum in general, right? Like this. There's a maximum right here. In f only occurs when what happens? When something increases and then decreases. Increases and then decreases. On f, so right here, luckily for me, it's right here. It increased and decreases. But I am given f prime. So I'm gonna look at this. So ideally, I wanna use this piece of information. So according to this, it must be when f prime changes from positive to negative. So I'm gonna look at my graph and I'm gonna go ahead and see where this changes from negative, from positive, right? From positive to negative. So I'm gonna look at my graph, this is all positive, right? Then I go negative. So at 2, it changed from positive to negative. So therefore, I have 1 already. X equals -2. Let's continue going. This is all negative, all negative, all negative, right? All the way to 1. And guess what? It continues being negative. So don't have to worry about that. Don't have to worry about that. This is still negative, still negative, still negative. And right here, I have no idea because the graph, we don't know any info about it. So our answer should be here because it changed from positive to negative on f prime. So keep in mind, guys, you already have all the information. Any questions so far? So let's go ahead and write our answer. I'll pick a darker marker. So pretty much this. I'm going to talk about what the function gave me, what function they're talking about. So they say f has a maximum. So I'm going to say that f has a maximum at x equals the value I just got, x equals -2, because this is acceptable in the AP exam, because, or you can write it out, I really don't mind, because, well, how did we know? Well, we were given the function f prime. So f prime, you could either use words or you could use symbols. Changed from positive to negative. So that is perfectly, that you talked about the graph that they wanted, you talked about the graph that you were given, and why. So this would be a perfectly good answer. And of course, guys, you could use different vocabulary. I really don't mind as long as the important stuff is there. F prime, the value, and the rationale. Okay, any questions so far?
Well, what would have happened? How would you find the absolute maximum?
That's
Or
an
absolute
excellent
minimum?
question, Albert. To find the absolute max, we need to know points on F. And here they didn't give us any. So this question would not work. But if they would have told us, hey, F of, I don't know, the endpoints, so F of -3 is -7, and F of, I don't know, 4 is 12, then I know, oh snap, the highest point I got, the highest height would be 12. Does that make sense? But it would have to tell you inside somewhere in here, but they don't tell us anything. Is that okay with you?
Okay. Yeah, that works.
Awesome. Okay, part B of this question says, on what open interval from the entire graph is both concave down and decreasing? So guess what, guys? We can use a fun chart here too. So fun and the f prime. Whoa. Sorry, guys. This is horrible now. This is bad. And f double prime. Plus and minus. Okay, so let's think about what they're saying. They're saying concave down. Let's go ahead and take a little pause right here with concavity. What is concavity talking about? What is even concavity? It's been like lots of months, I forgot. So it is talking about concave down, right? Concave down like a frown. That only
Curves.
happens when f double prime is negative, because the slope is decreasing. That's what concavity is talking about. Concavity talks about the slopes. What are they doing? Increasing or decreasing? And if we were to draw a little slope line right here, they're decreasing. Now f is decreasing. Well, how does a function decrease? Well, f decreases when the function is negative. So f decreases when the f prime is negative. So when f prime is negative, f prime is negative. So that's what we're going to go ahead and do. So we want to look at concave down. So concave down is here. And that comes when it is decreasing, when the function is decreasing, and when it is negative. So we need to look for these two characteristics, this right here and this right here. Now, in F prime, whenever it touches the x-axis, these are critical points. And minimums or maximums are also critical points. So, I'm sorry, not critical points, but have a horizontal tangents. So you need to check every single part and find out, do they match this characteristic and this characteristic right here? Because they want to know concave down and decreasing. Okay, so on from -3 to -2, this line right here, is it, let's go ahead and label this, this is going to be decreasing and this will be concave down. Okay, so is this decreasing? If I was on a roller coaster and going on this, I would totally be decreasing. Right, so this is met, the slopes is decreasing. Is it negative? So decreasing, yes. Negative, no. So it didn't work. Let's try the next section from -2 to -1. This little line, this little shape right here. Is it decreasing? If I was a roller coaster, would I be sliding down? It sure is. Is it negative? It's below the x-axis, so yes. So this is already one interval. And they want open interval, so -2 all the way to -1. Okay, let's try the next one. From -1 to 1. Is this decreasing?
Clearly not.
No. Is it negative? It sure is, right? It's below. So this does not work. Let's go ahead and try this one right here. This is decreasing. Yep. Because it looks like a little roller coaster is going down. Is it negative? Sure is, because it's below the x-axis. So I got another one. So union, whatever that interval was, from 1 to this horizontal tangent, which is 3. From 1 to 3. And last but not least, from 3 to 4, is it decreasing? Nope. Is it negative? Yes. So here's what I got. Any questions on that so far? No? Feel free to either unmute yourself, guys, or message on the chat, and I'll stop. This is like what was this? Unit 4 for us. So I know this was like lots of days ago. Okay. Let's see. So what is it gonna do? Oh yeah. So let's go ahead and answer this because it wants us to give a justification. So all we need to do is talk about the graph, talk about the intervals. It's open, so I would put open intervals on everything, and talk about how we found this out. So using my function. So I'm gonna say the function f is concave down. I don't know an abbreviation for this one that is AP friendly, I guess. So I'm just gonna write it down, concave down, and
CNC.
decreasing on, you can just say the interval, -2, -1, union 1, 3. Or you could say the inequality, but for me, this is just quicker and faster. I'm sorry, easier and faster. So, and then you just say, because it's acceptable, because, go over here. Well, why do I know this? Because, well, I was given f prime. And what about f prime? Well, it is this right here. We just said it was decreasing, and it was right here. It is negative, decreasing and negative. So we got that it was decreasing. It's decreasing and negative. And that's it, guys. You're good. You could also say this, f prime is decreasing. I'm sorry, you could say negative, f prime is negative. You could also say slope. You want to mention slope is decreasing, that works for me. Or you can say f double prime is negative, so f double prime is less than 0. Whatever as long as you use information about what you're given, you're golden. Like you don't have to make it any more difficult. I know at the beginning of the year I would try to like make it as intensely hard as I could, but over the year I've learned that hey, sometimes less is more, and you're good with this. This is perfectly fine. So, any questions, guys? No. Okay. Part C of this question. Oh, this one's good. All x coordinates of points of inflection.
I need to screenshot it.
Yep. Points of inflection, guys. Do we remember what points of inflection? This is also acceptable points of inflection.
Once it changes from concave down to concave up.
Yeah, when the concavity changes. Change in concavity. Yeah, and it really doesn't matter which way it changes. So let me go ahead and write this out. Oops, F, fun. This one shouldn't be that bad. We're trying to find out when concavity changes. So according to this, we can go ahead and look at this information right here. We're given F, right? And we want to find out when concavity changes, and that is associated with my F double prime. So I'm looking at when the slope changes. So we're going to look at this, and we're going to find out in what intervals our slope changes. So right here, I am decreasing, right? And right here, I'm increasing. So at this point, x equals -1. I went ahead and changed concavity. Then let me try it again. I'm increasing, 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 then decreasing. This right here, x equals 1. And one last one, the decrease and then increase, so at x equals 3. Because the change of slope. So point of inflection on F. Oh, how can I write this? When x equals -1, 1, and 3, because F prime, right? Because that's the graph I'm using, F prime. And then according to this, I am changing slopes. You could say changes slope. And I guess we can be a little bit more specific. From positive to negative, or negative to positive. Because I just wanted to leave it here, but then I thought about like, oh snap, like changes, like that could be anything, because our slope right here is 2, I'm sorry, -2, -3, -4, -5. So I need to change it a little bit more than that. So I think this will make it better. Any questions, guys? I think I only have, this one has one more last piece and we're golden.
Do you think I can go back to the other one just so I can screenshot all of it?
Sure. Got it, Albert?
Yeah.
Cool. Alrighty. Any questions on these guys?
Sure.
All right. The last one talks about finding a value, but now they gave us an initial condition. So this right here. So I don't know what the heck f is, right? And they want me to find 2 values. That's pretty tough, right? Because I have no idea what this graph looks like. The graph of f looks like. Because remember, if we integrate f prime, if we integrate f prime of x, that is the same thing as saying f of x, right? What I want plus some constant, right? And I don't know what the heck c is. So I'm stuck. The only thing I know is the following: the fundamental theorem of calculus. And of course, this initial condition. Well, luckily for you guys, that's all we need. So pretty much we can find this if we do the initial condition, which is 3 plus the integral of f prime. The integral from f prime. Okay. Now you're probably thinking, well, I don't know what the heck goes inside the little blanks. Well, just keep it like this. If this is the initial condition, I'm going to use absolutely everything I know. So if this is f of 1, the 1 right here will be my initial point. The 3 goes right here. Always, 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 always. And the 1 goes, that's just horrible. Sorry about that. And then you're probably wondering what goes right here in the x. Well, that's the x they want you to find. So this 4, you just put it right here. So if I want to find f of 4, it will be the equation 3 plus the initial all the way to the value that I have before, f of x dx. So take a second to find out what the heck this right here is talking about. So this right here, what does this remind you of? An integral from 1 to 4. Isn't an integral just the area under the curve? And do we know this area under the curve? Wasn't it just given to us at the beginning? The areas from 1 to 4 is 12 respectively. So that area right here is 12, but it is below, so it should be a negative area. So in reality, if you want to find f of 4, that is 3 plus negative 12. So I add these together, I get negative 9 as our answer. They're not saying to justify anything, but this is pretty much it. And then I'll say f of negative 2. So I'll go ahead and give you a couple seconds to try that one out. F of negative 2. And using the same equation, no matter what, the initial condition plus the value. 3 plus the integral 1.
3 plus negative 9 equals negative 6.
Okay. So I really like this question right here, just because of this right here, and it almost got me too. The lower bound, guys, has to be the smaller number. So is 1 smaller than negative 2?
No.
No, so that means 3, and I'm going to go ahead and fix that, negative 2, 1, f of x dx. But if I do that, guys, there's a rule that tells me that I need to go ahead and switch the sign. So
there you go.
Now it's 3 minus whatever the area from negative 2.
3 minus negative 9.
Whatever that was, this was 9, but it's below, so it's negative 9. 3 minus 9. So 3 plus 9, that gives me
12.
12. So if they were to ask you to make an equation to find any value for f, any value for f, and they did not give you any information except for an initial condition, you can make this equation as long as whatever the initial condition, you put it right here. And then the function. This always, always, always works. This is part of the fundamental theorem of calculus. Because the other option would be making an equation, guys, for every little line segment. And honestly, guys, that's going to take a long time. That will probably eat out the whole time you have for the exam. I am open for questions. That's all I have for you guys. As promised, I'm not going to overwhelm you with the questions. I just figured that this one's talk about a lot of topics. This is talking about Unit 4 and Unit 3, so that's a win, you know, since they say they're going to talk about multiple topics. Any questions, guys? Feel free to unmute yourself or put it in the chat, or you can message me privately and through here, and that should help you too. I'll try to answer it.
Those numbers 9 and 12, would they appear in the test? Like, would they just give you that area right in front of you right away?
So let me go ahead and show you the sample problems I have, Albert, and to prove your question. So check this out. This one right here, guys, this is geometry. You can go ahead and find that area without a problem, right? This have a semicircle, this is 2 triangles, this is a negative triangle, negative triangle. You can find that. In questions like these, Albert, to answer your questions, this is from 2013. They give you the area right on there. You know what I mean? And plus, guys, all the questions will be done without a calculator, so I don't expect them giving you impossible areas if they choose to go something like this. Just keep in mind they might add more letters because they need to test more units.
All right.
Okay.
Oh, sir, go back to the one where it involves a point of inflection.
Okay.
Because I have a key question there.
Yes.
What if the graph was not f prime, instead it was f?
I'm sorry? Oh, then you would just look at this, buddy.
Oh, what? The fun chart?
Yeah, you would just look at F itself. If this was just F, you need to go ahead and find out where the slope still changes. So you need to find out when this happens, when it's concave up and then it changes concave down, or concave down and then concave up. So if this was F, does it change concavity? This decreasing. So I would say somewhere right here would be my point of inflection. Would you agree? Because
Wait, how come?
Because this right here is concave up like a cup and this concave down. Oh, and then I would have another one right here, right? This would be concave up. Do you see that?
Oh, so if it's like in the points?
Within the points, what do you mean?
Like because you're telling me that at that point 0 it's like concave down, but then at the point of 2 it's concave up. So I guess you're putting that like around the points.
Yeah, around these points, right?
Yeah.
Yeah, I mean roughly, right? Because we don't know exactly.
Okay.
So I would say x equals 2-ish or 2, and this would be x equals 0-ish. I don't know, something like that. And give or take a couple shifts, right, left and right on the x value.
Okay. All right then.
Yeah, so that's a good question. But the fun chart, guys, whenever you see something like this, they're talking about increasing, decreasing. This is your best bet. This is a nice little hint that you can use. And to be honest with you, it helped us with the entire problem. So this is my proposal to you guys. Since I still haven't made the homework, I just found the questions. And I would like a little vote. I'll say this is, so option 1 is me making everything all multiple choice. So this right here, pros, I'll stop sharing now.